today we're going to base our discussion off the parts of a fillet weld. And the first part we want to discuss today is weld convexity. And weld convexity is this shaded region on the face of the weld. And weld convexity is weld reinforcement. It's another term for it. Let's say the vertical leg of this T-joint, if it were to try to break this direction, the added weld metal and the convexity is going to add strength to that weld to help hold it from failing. There are limitations to weld convexity. The American Welding Society sets the standards for all testing and measuring of welds. You're only allowed 1/8 inch of weld convexity. So, if we drew a straight line from point to point and we measured from here to the peak of this convexity, you're only allowed 1/8 inch of weld convexity. Now, let's say we have more than an 1/8 of an inch weld convexity. Certain circumstances will call for you to grind that excessive weld convexity down, or in critical testing, if you have more than 1/8 of an inch, you'll fail that test and either have to retake the test or, in worst case scenario, lose your job over it. So, weld convexity is a very important term for you to remember. Now, the second terms we're going to discuss, there's two of them, and those are the toes of a weld. Now, the toe is a very, very commonly referred to term. We want nice straight toes. We want what you call a wet end look, where you have smooth transitions at the toes of the weld. And now the best definition I can give you for the toe of the weld is where the weld metal meets the base metal. And like I said, we want that nice smooth transition. We do not want sharp corners. Let's say we had this weld here, and we had excessive weld convexity. These are the sharp corners I'm talking about. That's a great spot for a crack or a tear to start. And I'm going to demonstrate that using this piece of paper. I've got a nice square edge out of this corner and a nice radiused wet end look, we'll call it, out of this corner. Now, if I take very little pressure, and it's going to rip that sharp corner. Same thing with this weld. These sharp corners are going to tear every time. If this was to try to bend back, it's going to rip every time. Now, if we had a good, nice, smooth transition, we have all kinds of strength in our weld. Same way with this piece of paper. Now, the next term is right here, this circle. That's called our joint root. The joint root is virtually just a crack that is to be welded. Becomes very critical if we're taking a flat plate that's got a crack in it, not necessarily two pieces that come together to make a joint. If that flat plate has a crack, and let's say we're welding through there, we become off seam, or where the weld, you venture off of the crack. That's a huge problem. For one, you're introducing a lot of extra heat input to that base material. You're spreading out your heat affected zones. You're changing molecular structure of that steel that way. Now, from the joint root, which is here, to the toes of the weld, both ways, there's two. Those are called the leg of a weld. Now, the main thing the leg does, that determines the size of a fillet weld. Let's say we want a 1/2 inch fillet weld. That's going to require a 1/2 inch weld material from the joint root to the toe of the weld, both ways. Now, let's say we don't have equal legs. Let's say we have a 1/2 inch here and a 1/4 inch here. That's an unequal leg weld, or uneven leg, some people call it. Now, chances are your angles were too steep. You angled all your weld metal to the bottom plate and not both pieces. We want a nice 45-degree work angle coming out from the joint root. Now, what we're going to discuss now is right here. We got two of these as well. And these are what we call depth of fusion. Not abbreviate them. Depth of fusion. Okay, and fusion is how well that weld bonds to the existing base material. Commonly mistaken as depth of penetration. Now the difference between depth of fusion and depth of penetration is, like I said, depth of fusion is how well the entire weld fuses or bonds to the existing weld plate. And depth of fusion is how well, or how far that weld metal burns into the base material, okay? Depth of penetration is measured from the joint root to where the weld metal stops extending into the joint root or the base material, and that is our depth of penetration, okay? Now, we're going to discuss the throats of a weld. There's 3 different throats. And like I said, the throat is measured 45 degrees out from the joint root. First one we want to discuss very briefly, this is one that is very seldom ever referred to, and that's the theoretical throat. That's theoretically what a weld should look like. That's measured from the face of the weld without weld convexity to the joint root, okay? Like I said, it's very seldom ever referred to as, but the next one, this one is more so used than theoretical throat. It's from the face of the weld without weld convexity through the depth of penetration. Now, that's effectively what has to be there for that size calculation, a strength calculation, to hold. If it calls for a 1/2 inch weld material, not only is it measured out from joint root to toe both ways, it's also measured as the effective throat thickness. If we have a concave weld, where a weld metal is sunk in without weld convexity, not a straight line, where it's sunk in, you have insufficient effective throat thicknesses, okay? That's a huge problem in strength calculations. If they call for a 1/2 inch weld material and it's not there and you don't have that effective throat thickness, your yield strengths are going to be much less. Now, the last throat that we want to discuss today is our actual throat. That's pretty self-explanatory. Actually, what's there, okay? That's measured from the face of the weld with weld convexity through the depth of penetration. That's most commonly used. 99% of welds have weld convexity, therefore it is measured from the face of the weld with weld convexity through the depth of penetration. And these are all the most commonly referred to parts of a fillet weld that you will use in your everyday welding career.